Have you ever wondered what would happen if you could fire a bullet straight down into the center of the Earth? It's one of those wild what-if questions that seems pretty simple at first, but wow, it unpacks some absolutely incredible science about our planet. So let's dive in.
All right, so picture this. You're holding a really high-powered rifle, and you've got it pointed straight at the ground. You pull the trigger. What happens next? I mean, what really happens to that bullet? Does it just burrow a few feet? Does it somehow make it to the mantle? Let's follow its journey and find out.
Okay, first things first. For this thought experiment to even get off the ground, we have to imagine a pretty perfect scenario. Let's say the shot is perfectly vertical, and a magical tunnel just instantly appears in front of the bullet, clearing its path. So yeah, think of it less like a simple gunshot and more like an epic mission to the Earth's core.
You know, the second that bullet leaves the barrel, its journey and its problems have already begun. And its very first opponent, its first big hurdle, isn't rock or magma. It's something we move through every single day, without a second thought, the air itself.
Right, we tend to think of air as just empty space, right? But for a bullet screaming along at over twice the speed of sound, the air is basically like a thick fluid. Every single molecule of air it collides with pushes back, creating this incredibly powerful braking force. And that force is what we call air resistance.
So what you have is this constant battle between two forces. You've got gravity pulling the bullet down, trying to make it go faster, and then you have air resistance pushing up, trying to slow it down. Well, really quickly, those two forces find a balance point. The bullet stops accelerating and hits what we call its terminal velocity. And for a typical rifle bullet, that's only about 100 miles per hour. So all that incredible speed it had leaving the gun, yeah, that's pretty much gone before it even hits the dirt.
And then, impact. The bullet finishes its very short trip through the atmosphere and slams right into the Earth's crust. And this is the moment where the physics of our little problem change dramatically. The battle against the air is over, and a whole new war against solid matter is just getting started. The challenge has just escalated. I mean, look at this. The Earth's crust is over 2,000 times denser than the air. To put that in perspective, the difference is like going from a light jog through a park to sprinting full speed headfirst into a concrete wall. The resistance isn't just bigger, it's instantaneous and overwhelming.
So, let's just pretend for a second that our bullet could somehow keep going. This is the insane journey that lies ahead. It would have to blast through the solid rock of the crust, then plow through the semi-molten mantle, navigate a swirling core of liquid metal, and finally try to hit the solid inner core. Each layer is just exponentially more hostile than the last.
But it's not just about how dense the Earth is. As our bullet goes deeper, two other colossal forces join the fight: unimaginable pressure and incinerating heat. At this point, this isn't digging anymore. This is like trying to fly through a star.
The moment our bullet would theoretically enter the mantle, it gets hit by temperatures hovering around 2,000 degrees Celsius. Just so you know, that's about twice as hot as volcanic lava. And on top of that, the friction from just plowing through that super dense rock would generate even more heat, basically flash boiling the metal on contact.
And if you think that's hot, that is nothing compared to the core. If the bullet could magically make it that far, it'd be facing temperatures over 5,000 degrees Celsius. That's nearly as hot as the surface of the sun. There is no material known to man that could possibly survive that.
And then, there's the pressure. It's so hard to even wrap your head around, but this quote is such a perfect way to visualize it. Just imagine the weight of the entire planet above pushing down, squeezing everything with this unimaginable force. It isn't just a push. It's a crushing, compressing force that would literally atomize anything that isn't supposed to be there.
Okay, so let's recap. We've got extreme density, insane friction, incinerating heat, and absolutely crushing pressure. What does all of this mean for our little bullet? Well, its impossible journey comes to a very, very swift and definitive end.
So here it is, the reality of the situation. The bullet doesn't tunnel for miles. It doesn't even make it a few inches into the ground. The very instant it hits the crust, that combination of friction, pressure, and the Earth's own heat just vaporizes it. The lead and copper don't even have time to melt. They just flash into a tiny puff of metallic gas. The entire journey is over in way less than a millisecond. So, what do we actually learn from this impossible shot? Well, for one, it shows us that forces we usually ignore, like air resistance, are actually incredibly powerful. It also puts the truly impenetrable nature of our own planet into perspective. But I think most of all, it's just a stunning reminder of the violent, churning world of heat and pressure that exists just a few miles beneath our feet. The journey was over before it ever really began.
So yeah, while the bullet's journey is totally impossible, the physics behind why it's impossible are very, very real. It really makes you stop and wonder, what other incredible, powerful forces are shaping our world right under our feet that we never even stop to consider? It's pretty amazing to think about.